Je cherche trop, je cherche trop. Je cherche, je trouve.
What is artificial intelligence?
Hi, I've been looking into this artificial intelligence thing. It's fascinating. I investigated and spoke with experts and researchers. I read articles, attended conferences, delved deeper and dug. I went all the way to the Pharaoh's tomb. Basically, I went as far as I could. Watch out, this is serious stuff. By the way, we thought of you because we gave you all the sources. That way, you can check for yourself and, above all, explore the subjects that interest you. All good? Here we go.
The history of algorithms.
Algorithms are all around us. Content recommendations on Facebook are algorithms. GPS location that tells me about traffic jams is an algorithm. Facial recognition.
Algorithm.
Good. Yes, but what are algorithms? Let's start from the beginning. Computing. Computing is about processing information automatically. It relies on machines capable of processing data thanks to
Algorithms.
Good, Theo, that's good. You're with me. That's nice. Now, algorithms, stop me if I'm wrong, are a bit like a cooking recipe. It is a series of instructions to be followed in a certain order to perform a task automatically. Automatically means without the need to understand or think. This is perfect for a machine. Once you have this list of instructions, you translate it into a language that a computer can understand, and you get a computer program. Computers run any program that describes an algorithm perfectly and very quickly, and that's very impressive. Moreover, in the 1950s, researchers began to dream. They imagined algorithms that would make computers as intelligent as humans.
As Nicolas Rougier, an INRIA researcher, explains, there were some great advances up until the end of the 1970s, but then they were discouraged. The promised results were not forthcoming, research funds stopped flowing, and there was the first AI winter. 10 years later, there was a surge in expert systems that tried to reproduce the reasoning of a specialist such as a doctor. Still, the human knowledge had to be put into the machines, whereas what we wanted was for the machines to learn by themselves. A second AI winter happened at the end of the 1990s. A breakthrough came. Deep Blue IBM supercomputer beat the world chess champion Garry Kasparov. In 1916, another breakthrough, a Google algorithm beat one of the best Go players in the world, despite not having been thought possible for several years.
In fact, the history of artificial intelligence alternates between high-profile advances and major disappointments. Now we're back in the boom phase.
Have our computers become intelligent or not?
We should clearly understand and define what biological intelligence is to define artificial intelligence. Before, being an excellent chess player was a sign of intelligence. Today, that is no longer enough because the machine does it automatically. Biological intelligence is defined in the same way as artificial intelligence, which is a fascinating question. I'll try to explain to you today what biological intelligence is in 2020.
Biological intelligence.
At the same time as artificial intelligence, the cognitive sciences were born, which study human intelligence. They have made it possible to identify the various mechanisms at work in the way thought functions. This thought allows us to perceive, speak, move, memorize, reason, plan, be abstract at times, or creative for the best of us. These are our cognitive functions. To stimulate human intelligence, the idea was to reproduce cognitive functions. To achieve this, the researchers favoured two approaches, which are somewhat similar to how we learn, either through the transmission of knowledge or through trial and error, based on observation of the world and experimentation. The two complement each other.
The symbolic approach tries to imitate how humans reason logically and use their knowledge. As Thalita Fermo-Drummond, an INRIA doctoral student, explains, a certain amount of knowledge is transmitted to us through experiences, rules and procedures. This is how school learning, such as learning how to add, is done. When I add something, I can explain how I do it step by step. It is then possible to write a program explaining to the machine how to proceed step by step. The machine will then be able to perform it much faster than I can and without any mistakes. This approach has given rise to expert systems that try to reproduce the reasoning of a specialist, such as a doctor or lawyer, to solve a problem. This approach was very popular in the 1980s. Other knowledge comes from experience, where it is much more difficult to explain how it is achieved, such as riding a bike or recognizing a cat. I can explain to you how to ride a bike, but you'll only know how to ride if you pedal. You have to experience it. The other approach, the digital or connectionist approach, tries to imitate how humans learn by trial and error from their experiences. This approach is the one that is in the spotlight today.
You know, machine learning and the famous neural networks.
Okay, but you still haven't answered the real question. What is intelligence?
Biological intelligence? I'm getting there. Frédéric Alexandre, a computational neuroscience researcher, gives us the following answer. Intelligence means being able to respond quickly to a complex situation. Intelligence means finding the right answer rather than the best one. Intelligence means finding out what is important in the information. Intelligence means knowing how to adapt if conditions change, or how to react to an unexpected situation. All of this is done by using a strategy typical of living beings that combines emotion, motivation, and creativity. What is strong and specific about biological intelligence, which artificial intelligence does not have, is the complementarity of these emotional and logical aspects.
Yes, common sense.
Yes, common sense, if you like. Avoiding the illusions of general intelligence, which is far from the case. It would be better to speak of artificial intelligence in the plural. All the artificial intelligences we encounter in real life are just very technical and specific. They can only do the task that they have been programmed or configured for. A program that beats the world chess champion cannot recognize a duck. However, when it comes to a specific task, they are highly efficient, and often better than us.
From the lab to our homes.
In recent years, artificial intelligence has once again entered a phase of exponential development. This is thanks to the increase in available data, the processing power of computers, and the optimization of algorithms, of course. Voice or image recognition or translation programs, which were scoffed at a few years ago, now work in a way that can be astonishing, thanks to machine learning.
Artificial intelligence has emerged from laboratories and is now permeating and impacting all areas of society, from finance to agriculture, from medicine to education, and even into our homes. In today's digital world, we unknowingly encounter and use artificial intelligence in our everyday objects, cameras, recommendation systems on social networks, and connected speakers.
A world of algorithms. Humans must decide what the systems can do for us, not the other way around. As these technologies profoundly shape our society, understanding how they work is crucial.